Yeah, I'm really excited to talk about mapping typography today with you all. Can you all see my slides? Yes. Okay, great. Um, and I also have some exclusive CSS Café content in here as well. So excited to share some of that with you all. So most of us make websites. I think all of us make websites. And let's talk about the shape of what those are before we can start mapping things on top of that. So the shape of websites is multidimensional. What does that mean? So when we do print design, we tend to design in 2 dimensions. So there is the width of a page, and then there's the height of a page. It's a 2-dimensional object. We know kind of what we're working with there, and that there's nothing more than those 2 dimensions. Viewports are, by and large, 2-dimensional as well. We have a width and a height that we work with on that viewport. But websites are more than just one viewport, right? So they might be multiple different widths. So we have to work with that dimension. We can kind of extrude onto that dimension. There are also multiple different heights. We might have a dark mode and a light mode. And all of these factors go into our website, making it multidimensional, multifaceted object that we only see through the lens of a particular viewport that it is rendered on. So preferred font size, internationalization, scroll depth, different inputs, different outputs, different content, all of these different things change what we see when we render a website onto our page. So it's not just different viewports per se. We also put these, we work a lot in components, and we put these components onto a page. So in 2012, a long time ago, was working on SB Nation, and we had this complex homepage where all of these various content elements and components were placed. And why I'm bringing up such an old example is because for this, we had a different set of typographic rules for every entry type. So video posts, features, regular articles, fan posts, story streams, all had a different typographic treatment to them. And each one of these then had to restyle itself for every different, not just screen size, but placement within that layout. So this is complicated. You are incredible. You are designing these multifaceted, multidimensional objects every single day when you make a website, which is amazing. It's amazing that we can think in this way that is just beyond a 2-dimensional screen. It's like, how does that transform with all of these different constraints applied to our websites? And we manage this complexity by creating systems. We can call these design systems, something you all are, again, probably familiar with. So let's talk about a design system. This probably was not what you were expecting when we were talking about design system, but a typeface is like the original design system. So this is a font in a drawer, a physical font punched into metal that can then be printed onto paper. So how is this a design system? Well, when I used to be a typeface designer for a few years, and we would always start with these letters. So HOD, uppercase HOD, NOP. And the H, the uppercase H, you figure out the straights, the uprights, and how those fit together. With the O, you figure out the rounds. And then with the D, you figure out how the straights meet the rounds, right? And so with lowercase as well, the more upright forms, the rounds, and how those upright forms connect with those round areas. So this gives you the basic building blocks to start to extrapolate and build out some other characters. So then we move on to test word, something like hand gloves. We have the A and the G that provide a little bit more character. They go a little bit outside of this design system that we've established, but this provides the building block to build out to larger character sets. Here is the ASCII character set, and then eventually language support throughout Unicode is developed. And then this system that type designers create is built out for different optical sizes and weights. So this is starting to look like that diagram of the web's multi-dimensional website earlier. At different sizes, so at different screen sizes, you might think things get more legible for smaller areas, and then at larger sizes, you might have like bigger display type. More contrast between the size of the display text and the body copy. Think about that in terms of optical size of a typeface. So this is a very similar design space to what we work in on the web. Garrett Norchai created this graphic, and it is sort of the interpolation across the design space of an E within a typeface. So you could see this variation, this multidimensionality of how type designers think about what they are working with. Arrow type for their recursive release, this is at recursive.design, built a really interactive, really fun version of this Norchai cube that you can play around with and see in 3 dimensions what this design space looks like. Roslindale by David Jonathan Ross has a design space that doesn't look like a cube. As you get to smaller optical sizes, the width axis narrows down. So it has this really interesting shape to the design space that you're working within. And this is some older software, but type designers have been working with Interpolation to handle all of these different variations of their typeface. So this is Superpolator by Eric Van Blockland that really helps map this out. And you could see in the upper left-hand corner, there is a map of the design space, and you can drag a little cursor around on that area and navigate within that space to see how your typeface looks at different weights and sizes to turn out, all right, this is bold, this is light, this is italic, things like that. And Matthew Carter said something that's brilliant and has always stuck with me. He said that type is a beautiful group of letters, not a group of beautiful letters. And we can think about this, coming back to design systems themselves, and really any system is a beautiful group of things, not a group of beautiful things. So all of the parts need to work together. They can't shout above everything else. And I'd also like to think about design systems that they need to guide people to the right option. They can't just provide tons and tons of options to people. So how do we create that guidance? And with this in mind, I'd like to think about, with typography, so many of our design systems have a type scale. And this might be used in various components. It might limit our options to a few good options. But in thinking, all right, how does this guide our users of our design system to the right choices? It often just provides a number of choices for them. And just in fairness, I built modular scale on here, so I'm including my own stuff on here as well. But this this is a great way to, limit the number of choices, provide some good structure, but it doesn't necessarily guide people to making the right choices for what they are working with. So I just like to think about like building components around meaning. What does something mean semantically? So is it a CTA? Is it a byline? Is it a headline? What do these mean? And are there common threads that can connect these pieces, these different components as they scale up, scale down, or as they are displayed in different parts of our layouts, so that maybe we can have one headline and use that everywhere and have it have that semantic meaning, as opposed to picking an item off of our type scale. So again, this is not a website, but this text is structured in a way where, all right, if we're looking at this, the big headline is displayed in a much bigger area of the page, and the smaller headlines are displayed in much smaller areas of the page. Maybe there is some common thread between these that we can map out. So let's just look at these headlines, and then maybe, let's graph them, plot them onto a chart. So we have font size on one axis, and then the width of where that headline sits in the layout in this other axis. And we could start to draw connections between them. So just converting to pixels based on the image that we were using, you can see that there is this clear relationship between headline width and font size that maybe we can use to allow us to plot out some size that might be in between these as we are laying it out. And we know exactly what font size to use. So we have flexible grids, we have fluid media, but what about our typography? You might have seen clamp, viewport width, and now there's CQI. So this is the container query inline. So this is both logical as opposed to width. It uses inline and it queries the container. So that's what CQI means. It's the logical property for the container, or left to right languages, width. Just to get to basics as opposed to using any specific tool, I've plotted out that newspaper, those newspaper headlines onto a graph in Grapher, and then drawn a slope that somewhat matches that. So here's that equation for the slope that I might want to use. I can take that, convert it to CQI and REMS, and then I have some CSS to map that out on our page. There's also tools that help do this for you. So here is Utopia. It's at utopia.fyi, and it is building a clamp function that maps out that slope for us. So it's not too different from the equation that we came up with before. There it is. So this is what it might look like to map out a headline with CQI. So this is a quick demo, and every single one of these headlines and prices on this page just has one single CSS rule set applied to it. And it is just the context now that changes to make the size bigger or smaller. So these smaller products and smaller spaces of this page have smaller headlines. And then even the latest products headline at the top of the page is running on the same CSS rule set as all of the other headlines. So you could start to see how much more efficient you can develop things when you start to use styles that are intrinsic to whatever container they are being applied to. And here is that rule set. So you can see the font size and then the equation for that. This isn't using clamp. It does not have a maximum size. It will not go below 1.25 rems in size, but it will go much higher than that. So it's only using half of the clamp function. And so that's using max. And yeah, that is applied to all of the headlines on this page. Let's look at something a little bit more complicated. So this is the Atlantic. I have no affiliation with them. I just wanted to do a study to see what this would be like. So looking at the Atlantic, they have a number of headlines. Let's map that out just like we did with the newspaper. And instead of drawing a straight line through them, let's see what it looks like if we draw a map that's a little bit more complicated. So a nonlinear map through these different font sizes. And that allows us to do a lot of things. So here in real time, we are editing this map, and you could see that in a linear map, the text is not quite as dynamic, but we can make the headlines start much smaller and then ramp up more quickly to create more of a dynamic, more interesting typographic sizing and typographic shape on this page as it flows through the layout of our project. The added benefit is all of this is intrinsic to the size of the container. So as the container flexes, so does the typography within it. And we get responsification of all of these headlines for free. So across this whole website, one singular CSS rule set is being used for all of these headlines now. We don't have to create new breakpoints for them. We don't need to create new layout rules for them. All of this works, and this is a relatively complex typographic palette with a non-linear scaling applied to it. So that's for headlines. Can this approach to mapping typography in a nonlinear way also help with body copy? And this is particularly useful when we get down to really small screen sizes, so like the size of a watch, which we have so many devices out there right now. So here's a comparison between linear and curved, and both of these have the same ends to the spectrum, so they all go down to a font size of 0 at a width of 0, and then font size of about 20 pixels at a larger screen size. So the graph looks like this, and what we're trying to do is we're trying to keep the text as big as possible, as legible as possible, but we're trying to balance that with not chopping off the ends of words. They do have to get smaller as our viewport gets smaller, and these really small viewports are difficult to manage because the word cannot be longer than the amount of space we have on the page, or else you end up in this situation where you have to decide between different accessibility success criterion. So you don't want, you want to keep your text big and legible, but it also has to fit on a page. And at these really small sizes, we have to make this difficult decision between those. So it is a balancing act at very small screen sizes. So we've talked a little bit about font size. All of these demos interpolate these properties: font size, line height, font weight, and font width. Font weight and font width is something that you can do with this approach, but you cannot do with clamp. So that's talk a little bit more about that later. But we can also interpolate any interpolable property. So that is super exciting. So like color, all that kind of stuff. Here is just a quick showing. So all of these headlines are again using the same CSS rule set. but the weight is different, the character width is different. So you get this nice range of typographic headlines, but they all have consistency to them because they all share the same rule set. And as an aside, it's good to note specifically that line height is really important here. I've noticed time and time again that when something looks a little bit off, it's probably the line height. And it's not something that demos well, so that's why I'm calling it out explicitly. So as the line length increases, then you often want to increase the line height. So as the number of characters per line increases, then you want to increase the line height. And as it decreases, so like for headlines, because they're displayed bigger, there are not that many characters per line. So that's why we tend to have tighter headlines and longer body copy, or tighter headlines and more line height on the body copy. So here's a before and after with just reversing the line height options on both of these pieces of text. And it looks much better here, in my opinion. All right, so typographic maps define how our text flows and the shape of that through the shape of that text as it flows through our websites. This is what it looks like when sort of all of that text is flowing through these websites. But how the heck are we doing this? We have really powerful interpolation tools available for us today in CSS. Really exciting stuff. All of this is possible in CSS to control the shape of how things are being interpolated. And that's with CSS animations. So that map that you've seen before with a curved line, that is a cubic Bezier easing curve. So just a little bit of CSS trickery. Here's this is not using scroll timeline, but if you use animation delay, you can bind that to a custom property that is using JavaScript to change on scroll. So as that scroll event gets triggered, then the animation delay changes, and then this timeline is now bound to your scroll. You can also do things like mix colors. So CSS color stuff is, again, this is coming natively, but you can do this right now, or you could have done this for years now with just using CSS animations. So if you pause an animation halfway through its duration, then you have something that is interpolated between those two states. So here we're tinting, mixing, and adding shades to these colors, just using animation and pausing them at these particular points. Here's just a close-up so you could see mix. So using that mix between these two background colors, and then it is paused at 0.5 seconds of a 1 second, negative 0.5 seconds at a 1 second duration. So that's halfway between blue and lime. Here you can see another example. You don't have to do it halfway between. You can change up this interpolation function. All right, so now it's more towards lime. Cool. And yeah, we could do this with just CSS. So we've talked about how the animations work. Now let's talk a little bit about that delay, getting that delay to work. So this is coming hopefully soon to a browser near you, but it is already in the CSS spec. It is already part of a spec that has been implemented across browsers, but there's a little JavaScript that can fill in the gap. So what we're going to focus on in this part, which is the animation delay part, is this. So there's calc 100 CQI, so the container width for our cases, and divided by 1 pixel. This is probably going to break some of your brain, so we're going to dive a little bit deeper into this. Or you could do 100 CQI divided by 1 rem, and this gets the number of rems wide an element is. So this gets the number of pixels wide an element is. This gets the number of rems wide an element is. And yeah, CSS Café exclusive. CSS units are typed. They are really strongly typed. A CSS unit can be an integer, a number, a dimension, percentage, color. There are various types for CSS units. And so, just if you use calc and you take 20 pixels divided by 2, then you get 10 pixels. And the type is a dimension. So we are in here dividing a dimension by a number. It's an integer, but it's typed as a number. All right, so here we have 20 pixels, so a dimension divided by a color. And of course, we're going to get an error because these two things are not comparable. We also get an error in all current browsers if we do divide by any type that is not an integer, even if it does compare to the numerator of this function. So if we do 20 pixels divided by 2 pixels, we still get an error. But according to the current spec, as browsers implement it, this is what should be the results of calc 20 pixels divided by 2 pixels. So it should be 10, and it should be typed as a number, because if we'll go back to some basic algebra. Let's say we have 20 pixels over 2 pixels, so it's the same thing as the calc function. Let's just say 20x by 2x, so that we're trying to get a little bit closer to that algebra that we might know. We can cancel out the x because that's on both the top and the bottom to solve this function. So we can simplify that fraction to 10 over 1, which of course is 10. So that is how we get to that outcome. So let's look at our function 100 CQI divided by 1 rem. This CQI area of this function is constantly changing based on how it is rendered. So let's say we have a box that is 320 pixels wide. So that's the inline size of this box. So 100 CQI equals 320 pixels equals 20 rems in this particular context. So what we do is we take 100 CQI divided by 1 rem. Then we convert the numerator to rems, because we do this at runtime. We know what a rem is, and we can convert the numerator to a rem at runtime. Cancel out that, and then we're left with 20 rems. So the result of that function would be 20. And this can change depending on the box size. So as the box changes size, so here's 20. If it gets smaller, then it would result in 15 or 40. And all of this happens at runtime. If we want to use pixels, then we add pixels at the denominator. So divide by pixels. We get 320. 240 at this smaller size, or we can go up and the result is 640. Again, all real time at runtime. So we can take this unitless number, this value typed as a number, and then start to apply that to different things. Like we can multiply it by seconds and start to bring it into our animation function. We can just use the raw value in things like font weight if we wanted to do that. We can start to use this value in all of these different things, and have our CSS respond directly to the dimension of whatever box, whatever container we are styling, with, regardless of if it's color, dimension, whatever type we're using. So that is how that particular part of the calc spec works. That is where calc is going, hopefully soon. And this is what one of those typographic maps would look like. So we have this headline rule set with an associated set of keyframes. This animation timing function defines that shape of that curve, the shape of the map, as well as we're adding a min and a max value to it, so a min and a max point. And then sort of our smaller sizes of the rule set, and then our bigger size. So we don't have to do any math to figure out what our calc function looks like here. We just say, all right, what are font sizes at one point, what are font sizes at the other point, and how things interpolate between those two. Then this is the animation delay function. So this is how it all would work out in current CSS, but not in current browsers. We can condense that. So this piece of CSS would be used as support for that CSS rule set that I showed earlier. And then it would work. It would all be mapped out. So there's the 100 CQI, and then those points of division are dividing by 1 pixel are where current browser implementations fall short into making this actually work. So we can get around this by using resize observer and then passing that through to a CSS variable. So we can use JavaScript, we can resize observer to say, all right, how wide is an element in a unitless value? So sidestepping that calc issue. So that can be replaced by a bind function, and that bind CSS variable that is written with JavaScript can then make the rest of this animation function work, so that we can map our typography. Here is what a working version of that rule set of that might look like. So this is for the base styles, the base typographic styles for a page. Here's a rule set for a headline, and let's see how all this comes together. So yeah, here's this demo, and it is using those two pieces of just those two rule sets before. It's fully responsive down to really tiny sizes without text having to break and overflow its container. But as we get up to a reasonable font size as soon as we have space for it. And you could see that different variable font settings are starting to be at play here. So we get sort of that rich, dynamic, those rich and dynamic headline changes as at the bigger sizes. You don't even need to use this stuff for typography. So linandtonic.com, Lynn Fisher just made this like last year, 2 years ago. And this was she redesigns her site every year. And she used this approach to make this really cool animation as you resize the browser on her website. If you have not seen it already, definitely recommend checking it out. But yeah, it's using this exact same approach and exact same code to create these animations as you scale up and scale down the browser. built this demo so you could work really quickly. Worked with Alex Trost on this one on his live stream. And it's fun to play with like rich and dynamic home pages that can scale at different sizes, and not have to worry about redoing the typography as the page scales up and scales down. So you could start to play with layout a lot more and build pages quickly when the text styles can adapt to the context that they are placed into. And we've looked at a lot of this text in the context of layouts, but this is an example of like what the shape of the text itself looks like. So you could see that it has some curve to it. Variable font settings are being applied, and this is what the shape of these mapped typographic components looked like. So yeah, this is how I think about mapping typography. Our web pages are fluid and dynamic, and this is how the text flows through them. This allows you to have control over how your styles are interpolated, and that can be extremely powerful. There are huge opportunities with new calc features and animations that I'm extremely excited about, and I really am excited to share them all with you. So thank you so much. Happy typesetting.